Hello guys, I am Munot and welcome to the School of Physics, and today we are going to study thermodynamics. Thermodynamics is a very easy topic. I'll summarize everything that you need to learn in thermodynamics in a chart form. So basically the questions that come are from either the Carnot cycle or the work done in different processes. So I'll summarize all the work done in different processes in just one chart and all the properties. So you need to understand there are 4 types of works that we are going to see. Okay, so this is the pressure on the y-axis and this is the volume on the x-axis. Now the first kind of work that I am going to talk about is when from point 1 to point 2 pressure remains constant. Okay, so pressure remain constant, which means that delta P is equal to 0. So in this case when delta P equals to 0, work done is equal to P into V final minus V initial. P into V final minus V initial is the work done. Okay, now other things, let's talk about other things as well. So for any process PV की power gamma, okay, for any process PV की power gamma, this constant C is equal to R upon gamma minus 1 plus R upon, so or say for any process, polytropic process PV की power x, R upon gamma minus 1 plus R upon 1 minus x. Now this R upon gamma minus 1, as we have studied, is CV. So C is equal to R upon gamma minus 1 plus R upon 1 minus x. Okay, so coming back to the thing, from 1 to 2. So here work done is equal to 0. Work done is equal to P V2 minus V1. Delta P is equal to 0. And when we talk about bulk modulus, it is equals to 0 and C is equal to Cp. As we have studied in our KTG chapter, C is equal to Cp. Okay, specific heat capacity chapter, C is equal to Cp. Bulk modulus is equal to 0. Okay, the next process that we are coming to is something like this. So this is an isothermal process. Isothermal process means delta T is equal to 0. Isothermal process can also mean that change in internal energy is equal to 0. So in this case work done will be equal to, formula for work done will be equal to nRT ln V2 by V1, or nR ln V2 by V1 and nR ln P1 by P2. Okay, so nR ln V2 by V1 and nRT ln P1 by P2. So nRT ln V2 by V1 and nRT ln P1 by P2. So this is the work done. Okay, and in this case bulk modulus and C. Okay, so in this case the bulk modulus will be something, say it will be equal to P, and the C in this case would be equal to infinity. The C would be equal to infinity. Okay, the third process that we are coming to is adiabatic process. Remember, first comes on the graph, first comes isobaric, then isothermal, then adiabatic. Okay, in adiabatic we know that the energy given is 0. The external energy given is equal to 0 and the work done is said to be P1 V2, P1 V1, P initial V initial, P1 V1 minus P2 V2 upon gamma, that is adiabatic constant, minus 1, or work done can also be written as NCV T1 minus T2. NCV T1 minus T2. So this is the formula for work done. Bulk modulus in this case is equal to gamma into pressure and C is equal to 0. Okay, the fourth work that we are going to see, so this is isobaric, isothermal, adiabatic. Remember, the slope of adiabatic is always lesser than isothermal. And the fourth work that we are going to see is isochoric. So in isochoric, what happens is, so in isochoric, I am writing it down here. In isochoric, change in volume is equal to 0. Since change in volume equals to 0, work done equals to 0. Bulk modulus is equal to minus infinity, and C is equal to CV. Okay, C equals to CV. Now you have to remember this chart. This chart is very important. You are getting all the work done and everything that you need for all the processes covered up. Okay, so have a look. I am giving you for some 30 seconds. Have a look of this chart, copy it down. Very important chart. And also this is a very important formula. C is equal to R upon gamma minus 1 plus R upon 1 minus X. Talking about the basic laws of thermodynamics. Okay, so the basic laws of thermodynamics are zeroth law. As you all know what zeroth law is, that suppose I have a body, A, B and C. So A, B and C, talking about the zeroth law. So if A is in equilibrium with B and A is in equilibrium with C, then B and C are also in thermal equilibrium. So if A is in thermal equilibrium with B, A is in thermal equilibrium with C, then B and C are automatically in thermal equilibrium. Then this is the zeroth law. Then there is the first law. First law says that the heat given goes into changing the internal energy, and the work done, heat given is equal goes into changing in internal energy and the work done. We follow the sign conventions. What are the sign conventions? Sign conventions are heat given to the system is positive, taken away from the system is negative. Heat given to the system is positive, taken away from the system is negative. Work done by the system is positive. I tell again, work done by the system is positive and work done on the system is negative. This is unlike chemistry, in which in chemistry we used to see work done on the system is positive. Here work done on the system is negative. In chemistry, work done by the system is negative. Here work done by the system is positive. Okay, sign conventions very important. You have to keep them in mind. Okay, the next thing that we are going to see. Okay, one more thing, adiabatic. So for adiabatic, I'll just remove all this. Okay, for adiabatic, this is a very commonly asked question. For adiabatic process, this is an adiabatic process, suppose, right? So this is an adiabatic process. So here I have, this is also an adiabatic, this is also an adiabatic. So you have to arrange what is the gamma. We saw gamma for monatomic is 1.67, then for diatomic it's 1.40, then for diatomic, polyatomic, non-linear, this is for linear, it is 1.33. So we have to place. So I wanted to say that 1.67 gamma is this adiabatic, then 1.40 gamma is this adiabatic, and 1.33 gamma is this adiabatic. Means the adiabatic which has the highest gamma will be downer in the slope, then this will be the upper one in the slope. So when we go clockwise, we go towards a higher gamma. Whenever we go clockwise, so suppose this is an adiabatic and this is an adiabatic. So which one has highest gamma? When we go clockwise, the higher we go towards higher gamma. So this gamma will be greater than this gamma. Okay, so whenever we go clockwise, we go towards a higher gamma. Okay, so this concept is done. Okay, now we go to heat engines and Carnot cycles. So what happens in heat engines? Tell me. So in heat engine we say, suppose I have this block of temperature T1, it is giving an energy Q1, and then this is my work process. Here W1 work is taken from Q1 and Q2 heat is released and it goes to T2. Now, very commonly when asked question, what is the efficiency of this heat engine? So we'll write it down. Efficiency of this heat engine is equal to 1 minus Q2 by Q1, or it will be equals to 1 minus T2 by T1. Okay, so this is the efficiency in fractions. In percentage, you have to multiply this by 100. So this is the efficiency in fractions. Okay, then this is for the heat engine. This is for the heat engine or Carnot cycle Now there is a refrigerator also. So in case of refrigerator, okay, so in case of refrigerator, what happens is that this T2 gives some heat Q2, and also there is this work done on the system W1. Okay, and then this energy Q1 goes out. So this is the case of refrigerator. So in case of refrigerator, we write the efficiency as Q2 upon work done. So this is also written as Q2. This in mind, this is Q1 by Q2, Q1 minus Q2. Why? Because in case of refrigerator, we have Q2 plus W is equal to Q1. So what is the work done? Work done is equal to Q1 minus Q2. Okay, then this is the refrigerator case. Efficiency is equal to, or the coefficient of performance is equal to Q2 upon Q1 minus Q2. Okay, then I have, these are very simple and very common questions that are asked. That they'll give you some PV curve, any kind of a PV curve. Okay, so they give you some kind of a PV curve, and then they ask you what is the work done. Okay, so this is some kind of a PV work. So work done will be equals to area in the enclosed by PV curve. So you just have to find the area under this PV curve. So that will be the work done in this case. Okay, then there can be some cyclic also. So work done can be cyclic like this. So in this case, or work done can be clockwise or anti-clockwise. Okay, work done can be above the axis or even below the axis. Okay, and work done can be below the axis, above the axis, like it is said like here. So in this case, you have to consider it in mind that work done clockwise is positive, anti-clockwise is negative. Okay, and then above x-axis is positive, and below x-axis work done is negative. So this is what you have to remember. Now we finish our chapter. So guys, this was a chapter on thermodynamics, and I hope you enjoyed the lecture. Please keep on revising these revision videos, because you'll get a very tight hold of all the formulas which you will directly apply in the exam. I hope these videos are helpful to you.